Hello everyone, a very warm welcome to my seminar presentation. Good morning, good afternoon and good evening, depending upon time you are watching this video. Thank you for being here. For those who don't know me, my name is Pratyush Chaudhary. I am final year student of B.Tech Civil Engineering Department studying in Faculty of Engineering and Technology, University of Lucknow, accredited A++ by NAAC. I would like to introduce a seminar presentation which is on topic Building Information Modeling under the guidance of Engineer Jiten Pratap Singh sir. My whole presentation consists of what is B.I.M, its history, why it is used, why B.I.M is important, what are the different levels of B.I.M's construction, case studies, the future of B.I.M, what are the benefits of B.I.M, advantage and 3D visualization, and finally conclusion. Now, what is building information modeling? Building information modeling is the linking of people, technology, and processes to improve outcomes in building and construction. It is an intelligent 3D model based process that provides architecture, engineering, construction professionals with every detail need to plan, design, construct, and manage buildings and information. Building information modeling is also known as building information management because from design to build till operate, everything is managed in this. Building information modeling can be used in different industries, but in architecture, it is used to make better design decisions, improve building performance, and collaborate more effectively through the project lifecycle. It is the latest evolution of building industry and it refers to the process of designing, building and operating a building collaboratively using single coherent system of 3D models rather than separate design drawings. Now moving further. In this slide, I am going to give a brief history of building information modeling. It was started in the late 1970s. Chuck Eastman created the first tool for modeling buildings in late 1970s called Building Description System. Another early pioneer in this field was Jonathan Ingram, who worked on GAP, Sonata and Reflex software. The term building model was first used in papers in mid 1980s. In 1985, a paper by Simon Ruffle, later in 1986, a paper by Robert Ash. World first actual B.I.M, that is Building Information Modeling Capable Program, Sonata, was released in 1986 by Jonathan Ingram. In 2002, Autodesk released a white paper entitled Building Information Modeling. That was the first time where building information modeling word was introduced. Now move to further. Now, why BIM is used? Building information technology is used to manage information on construction project across the project lifecycle. It is the digital description of every aspect of the build assessed and provide modeling and management information which enables all the parties to work to the same standard and to be kept in the loop regarding any update and changes. Additional benefits include better project coordination and collaboration with stakeholders, efficient workflow, 3D visualization, and overall improved project outcomes. Some of the points which I have included here, that is, building information modeling is used to improve the efficiency of construction processes, reduce waste during the construction, and improve the quality of the buildings. Better collaboration and cooperation between the parties involved in build every phase of building process from early planning to design to construct, operation, maintenance and final recycling is captured digitally in building information modeling system. Now move to further. It is the great achievement for building information modeling is that the World Economic Forum has pronounced building information modeling a fourth industrial revolution where connected machines feeding from data will exponentially transform processes in every industry. Why building information modeling is important was illustrated by Patrick McLamy. In 2004, Patrick McLamy drew a set of curves based on pretty self-evident observation. An architectural project becomes more difficult to change the more developed it becomes. For this earth-shattering revelation, McLamy named the curve after himself. It gets taught out in every slide deck promoting building information modeling. The key point is that architectures expel their effort at a time when design changes are relatively costly. McLemay and his discipline advocate shifting design effort forward in the project, front-loading it in order to reduce the cost of design changes. McLemay would argue that shifting design effort towards is for the benefit of design. Now, what are the different building information levels involved in building information modeling construction? Different levels of building information modeling can be achieved by various types of project. Each level represents a different set of criteria that demonstrate a particular level of maturity. B.I.M level start with 0 and go to 4D, 5D, and even 6D B.I.Ms, where D represents dimension. Each level is determined by how much information is shared and managed throughout the process. Take a look at the criteria needed to determine which level you are working at. Level 0 BIM, that is paper-based drawing plus zero collaboration. Level 1 BIM include 2D construction drawings plus some 3D modeling. Level 2 BIM, team works in their own 3D models. Level 3 BIM, team works with a shared 3D model. Level 4, 5, 6 BIM, adding a schedule, cost, and sustainability information. This figures explains that how the project construction design efficiency increases as we increases the level of the project. Like in level 4 and 5, we add scheduling, cost, and level 6 sustainability information. Earlier, engineers and architecture were limited to paper-based drawings in which they can show only two-dimensional and three-dimension of a building model. But in building information modeling, we can enlist 4 dimension, 5 dimension, and 6 dimension of the building. So what is 4 dimension building? That is 4D beam. It enlists the timeline of construction process on site by adding a new element to the model, that is time. Scheduling data with time consideration helps track the site progress, understand the construction timelines, and better gauge project evolution. Now what is 5 dimension beam? That is 5D beam. 5D beam aids in aligning budget and estimation right from the project concept stage. 5D beam enables project promoters and builders to analyze the cost beforehand, eliminating any cost, led delay, or compromise in the project. Hence, 5D beam dimension make money management easy and bring transparency. It helps to optimize and plan the budget, keeping every stakeholders aligned with the process. Finally, 6 dimension beam, that is 6D beam, also known as integrated beam. The 6D beam dimension add not only in analyzing building consumption of building, but also in coming out with energy estimates, aligning the building performance in terms of energy requirement and decommissioning information, ensure a price precision of energy consumption data, giving an idea of the cost of an asset in a project cycle. Now move on to the case studies. I have included two case studies in this video. The purpose of case studies is to illustrate various tangible and intangible benefits achieved by developing and using building information models for actual construction projects. Case study 1, that is Aquarium Hilton Garden in Atlanta, Georgia. The Hilton Atlanta near the Georgia Aquarium was constructed by Holder Construction with the use of building information modeling. The total investment was $46 million, dollars, with the cost of building information modeling implementation constituting $90,000 or 2% of that investment. The whole area was 484,000 square feet, hotel and parking structure. Honda Construction developed architectural, structure, and mechanical digital models that were used to identify and predict the 590 classes before construction began. This analysis is combination with outstanding cooperation between architecture engineers and contractors during the design phase resulted in the successful implementation of B.I.M with overall saving of around $600,000 and 1,143 work hours. The 3D models were used to communicate with the owners and also in early decision making, with a substantial benefit for the construction phase. Finally, the documentation of the building and its correspondence to an accurate digital model provided a valuable database for building maintenance. My second case study is based on Odense University Hospital, that is Denmark's largest hospital project. The Odense Hospital Center focuses on the people and the relation and integration with the surrounding environment. CMB has carried out the design phase, developed with building information modeling methodology, optimizing all qualitative standards from energy consumption to the aesthetic quality of the design project to the comfort of the interiors. The hospital extends over an area of 860,000 meters square, which has allocated budget of around 600 million euros, which was scheduled to deliver in 2022. It is also known as Hospital of Future. 36,000 design drawings, 60 lifts and almost 9,000 doors for capacity of approximately 10,000 rooms, more than 70 operating theaters, 70 ICU beds and 68 day hospital beds. These are just some of the numbers of Denmark's largest hospital complex. The hospital complex is the most extensive in Denmark, to be completed in rapid time. It composed of 6 buildings arranged systematically with respect to the central body, which functions as a backbone and link the university to the main entrance. The building's bodies are 4 or 5 story high for the total surface area of over 250,000 square meter. For the choice of materials, particular attention has been given to the sustainability so as to create an eco-sustainable building with minimal energy consumption. The development of the project was implemented in building information modeling, which will ensure an increase in productivity and precision. This is the Odense University Hospital plan. It composed of 6 buildings arranged systematically with respect to the central body. The buildings' bodies are 4 or 5 story high for a total surface area of over 250,000 square meter. Nowadays in India, architects and engineers also using building information modeling for the constructions of many projects. I have included two of them in this video. That is, first, Indian Railway Gwalior Station. The station has been proposed to redevelop at the cost of rupees 240 crore and proposed the site area for developed is approximately 2,30,425 square meters. And second one is Bangalore International Airport, which utilizes Autodesk B.I.M 360 as a design and planning platform for the construction of the project. And now moving on further, what are the benefits of the BIM? Building information modeling brings together all information about each individual component of a building in one easy accessible place. It makes it possible for everyone to access that information for any purpose and to integrate different aspects of the design more effectively. There are a few more points which I have written in this slide, that is modernize the bidding process, basing it on accurate take-off of the building materials can significantly lower carbon emissions during construction, optimizing mechanical, electrical and plumbing systems in the design phase, lowers electricity and water consumption during operation, enables predictive maintenance, and lowers the lifetime cost of the building. The other advantage of building information modeling is that decision making, feasibility versus viability, and option selections. That is, in figure A, B, and C, the people can change the color, design, and what are the other elements they want to include. That is, design alternatives, design constructability, and budget planning and material selections. This slide shows how a residential building visualizations includes energy analysis, structural detailing, bills and quantities, and prefabrication of the structure. Figure number 29, figure number 33 and figure number 31 shows the 3D visualization of service planning and 3D modeling of clash point checking and solution of prefabrications. Figure 32, 33 and 34 shows 3D visualization of structural beam modeling. The steel structural beam model, general arrangement and detailed drawings, shop drawings are shown in these figures. Now, the future of BIM. Till now, we have seen the advantage and what are the benefits of the building information modeling, and we have studied somewhat detail about it. The future of BIM is both exciting and challenging. Because of clear benefits, BIM is there to stay. It has defined goals and objectives that are clearly beneficial to all those who work their way through the levels. Highly collaborative and digital. As BIM becomes increasingly more sophisticated, 4D, 5D, and even 6D BIM will start to play a part in the process. Furthermore, around the globe, there is an attempt to reduce the waste in construction, in which building information modeling is also playing an important role. By working collaboratively in building information modeling environment, all this becomes such less likely, setting the stage for a better tomorrow. In the conclusion part, we are going to conclude the whole seminar presentation. Building information modeling has emerged as an innovative way to manage projects. Many researchers and practitioners have indicated that the building information technology is set to become indispensable to building design and construction as probable T-square or hammer and nail. As the use of building information modeling accelerates, collaboration within project teams should increase, which will lead to improve the profitability, reduce costs, better time management, and improve the customer-client relationships. Building information modeling, practicability of information of building performance and operation is greatly improved by adopting building information modeling. It is hoped that the increasing use of building information modeling will enhance the collaboration and reduce the fragmentation of architecture, engineering, and construction industry and eventually lead to improved performance and reduced project cost. Using building information modeling as a tool to update the flow of information during a project is just critical as doing it the first time. Building information modeling tool will continue to develop in their ability to be streamlined, be but current process allow building information modeling enabled construction manager to complete tasks within relatively good efficiency. The references which I have used for the preparation of this seminar presentation, that is research papers, websites and video used, has been given in this slide. You can go through that and get more information about building information modeling. Thank you for giving your precious time for the video. If you have got any queries, please comment it below, like the video, share it and subscribe the channel for get updated for new videos. Thank you.